Good evening, students. As we complete the first part distance formula, so now here again we take the same example. Let's see here PQ. So P is the point 1, 2 and Q is the point 2, 3. So now here with the help of distance formula we find out the result 2 minus 1 whole square. Already we have done this. Now you see here from P to Q, whatever the distance we consider from Q to P, the distance is same. So the same formula we can write in oppositely also. So like the points are given P and Q, but if you find out the distance between Q and P, so what you have to write? 1 minus 2 whole square and 2 minus 3 whole square. If you calculate these two, you see both the results are same. So as many questions are asked me in WhatsApp group that the results are not coming same. Actually the values are you write different way, but if you calculate you get the same result. Is it clear? So I think now there is no problem. The distance between P and Q and the distance between Q and P, the results are same you get finally. Okay, let's take an example here. Now one question we write here and the question is this one: find the point on the x-axis which is equidistant from the point 2, minus 5 and minus 2, 9. So this question is very important and common question examination point of view. So now here first of all the condition is given, find the point on x-axis. So as we know already we discussed, when a point lies on x-axis, y coordinate is 0. So that's why first of all what we have done, first point we consider 2, minus 5 here we consider as A, and second point we consider minus 2, 3 here. See, so now in between we consider a point B, and the coordinate of B we write x, 0. Reason behind, the point lies on x-axis, so that's why this y coordinate is 0, and the x coordinate we don't know, so that's why we write x. So x, 0. Is it clear? Now according to the condition, whatever the point we consider, it is equidistant. What is the meaning of equidistant? So now here A, B, C, 3 points are there. So distance, whatever the distance from A to B, the same length we get from B to C also. This is known as equidistant. The length of AB as well as the length of BC are same. Is it clear? So according to the question, equidistant mentioned, so that's why we write AB equal to BC. Now in A and B we can apply the distance formula. Similarly in B and C we can apply the distance formula. Is it clear? Now first of all, to calculate this result we have to eliminate this square root over sign. So for that reason what we have to do, we have to squaring both sides. If you squaring both sides, this root over sign gone, then after that this result you get. And if you break this one in the form of a plus b, a minus b whole square, then after that if you calculate, then you get the value of x from here, and this x value if you put here, then you get the b coordinate, and which one is your required answer. Is it clear? Okay, now students, after distance formula, in our content the next topic is section formula. You have seen here, so section formula. So now today we discuss about this section formula. So for this what happened, so first of all 2 points are we have to consider. First point is we consider A, x1, y1, and another point is here at this place we consider B, x2, y2. So in between this A and B we have to consider a point P, xy. Is it clear? So now here from A to P, the distances we consider as an m1, the length from A to P. Similarly from P to B, the length is we consider m2. Listen carefully. So from A to P we consider the length is m1, and from P to B we consider the length is m2. Now we have taken this one as a ratio, m1 is to m2. That means this two part, m1 is to m2. Now here if the ratio is m1 is to m2, so how can we separate these 2 points A, B in the ratio of m1 is to m2. This formula here we have to apply here, and this formula is not only actually section formula. Here section formula, there are two results are there, one is internally, another one is externally. So we have to discuss about the internal. So that means our main task is we have to find out this pxy, this point we have to find out with the help of this ratio. Now how can we write down the formula here? You see, first of all, the ratio is m1 is to m2. So here you see the red marks. This m1 goes and multiply with x2. Is it clear? And then secondly, this m2, the red mark, multiply with x1. So that's why we write here m1 x2. You see here m1 into x2 plus, remember, plus m2 into x1, m2 into x1. You see these two red marks, and divided by the sum of the ratios. That means m1 plus m2. You see the m1 plus m2. Is it clear? Similarly, for y coordinate, what we have to do, again you see the blue marks here. m1 we have to multiply y2. So that's why we write m1 y2 plus, second one is m2 we have to multiply with y1. So that's why m2 y1, and divided by m1 plus m2. Very simple and very easy. This one is the formula, section formula internally. Remember, internally. So here what happened to, what given to you, actually the 2 points are given to you, and with respect to this ratio is given. If ratio is given, this p point easily you can find out. Is it clear? Sometimes the ratio given, this b point given, and this p point given to you, so easily you can find out a. Similarly, if a given, b given, or p given, then you can find out the ratio. And in the same way, if a point, ratio, and p point given to you, then easily you can find out b. So in 4 different way here the questions are asked. So next, another special case is here. You see, so here we consider the ratios are the length of a to b is m1, p to b is m2. If their distances are same, that means equidistant. If their distances are same, that means if their ratios are same. So if ratios are same, then we can write this one is 1:1 also in place of m1 is to m2, because from here a to p, if the length is m1, and in the same time if p to b the length is also m1, then m1 divided by m1, what we get? 1:1. So in place of this one, that's why we write here 1:1. Is it clear? All of you understood this? What we write? Again I repeat this one. From a to p if the length is m1, and from p to b if the length is m1, suppose equidistant, then m1 is to m1. That means m1 by m1. That means 1:1. So that's why we write here 1:1. In this case, if this p point, when we get this one is equidistant, obviously in from a to b the p is the midpoint. If p is the midpoint, then these two lengths are equal. So that's why this one is also known as midpoint formula also. Is it clear? So now in this case, what you have to do, let's say if you write down the same ratio, whatever the technique we apply here, the same technique we have to apply here, 1 into x2, that's why we write here 1 into x2 plus 1 into x1, 1 into x1. Similarly 1 into y2 here plus 1 into y1. Is it clear? And the ratio is 1:1, so that's why 1 plus 1, 1 plus 1. So if you calculate this one, so x2 plus x1 divided by 2, y2 plus y1 divided by 2. So the section formula internally, if you are applying the midpoint formula, then the midpoint formula is we have to write this one. Is it clear? Now let's take an example here. So 2 points are we consider. One point is 4 minus 3 and another point is 8,5. And the ratio is we consider in the ratio 3:1. Internally we have to find out. That means the first point is given, second point is given, the ratio is also given. So we have to find out this point. That means which one? The p point. P point we have to find out. So how can you find out? Applying the technique here, you see 3 we have to multiply with 8. According to this m1 into x2, so that means 3 into 8 plus 1 into 4. So that's why 3 into 8, 1 into 4, and the ratio is 3:1. So that's why we write 3 plus 1. Is it clear? And the next one is what we have to write: 3 into 5. 3 into 5, 1 into minus 3. 1 into minus 3, 3 plus 1. So if you calculate these two, then the result is you get here 7, 3. Is it clear? I think no problem here. Okay. Now let's take another example. This one is actually from exercise 7.2 question number 4. If you see exercise 7.2 question number 4, this one is the question. Now in this case, what happened? We have to find out the ratio. Is it clear? If you read the question carefully, there the 2 points are given, and at the same time P point is also given. Here you have to find out the ratio. So when we have to find out the ratio always we have to consider in such a way that k:1. Is it clear? Remember this. Always we have to assume the ratio is in the form of k:1. Clear? Now the other all points are given to you, and the ratio is you consider k:1, and again we have to apply the same technique. So the question is arise here, why we consider the ratio like in this way, k:1. Because here k:1 means k by 1 means meaning is the k. So very easily we calculate the result. But if you consider the ratio is m1 is to m2, so in both cases we have to find out m1 as well as m2 also. So there a little bit calculation we have to do. So for that reason we have to consider the ratio is k:1. Is it clear? Not 1:k. We have to consider k:1. Okay. Now here if you apply the section formula internally, so k obviously we have to multiply with 6, and 1 we have to multiply with -3. As we know the technique, so k into 6, 1 into -3. You see. Secondly, k into -8, 1 into 10. K into -8, 1 into 10. And the ratio is k:1, so that's why we have to write k plus 1 here. You see. Is it clear? And the point is given to you -1 and 6. So that's why here in place of xy we write -1 and 6. Is it clear? Now this first part is the x coordinate and the second part is the y coordinate. Is it clear? So now what we have to do, we have to compare this x coordinate with x part and y coordinate is with y part. So if you compare anyone, so here both are compared here, so you can compare anyone. Suppose if we consider the first part, here the x coordinate is -1, here x coordinate means this whole part, so -1 equal to this part. So if you calculate, then the result you get k equal to 2/7. K means we can write k:1 also, so k:1 equals to 2:7. Is it clear? So this one is our required answer. If you get the ratio in one part, so no need to find out the next part, because here also if you calculate you get the same result. Is it clear? So in this way you have to find out the ratio. Now if you consider another example, suppose if you see here lots of points are given here, A, B, C, D. So if you see here how many parts are there, first part, second part, third part. So this one is known as trisection. A line we have to separate into 3 parts, so that's why trisection. 2 parts bisection. So here trisection 3 parts. So the first part, and here how many parts are there, second part, third part. Here 2 parts are there. So in between A to C or in between A to D or in between B to D, you can in different way you can find out the result. So now first of all, if you take from A to D, you see from A to D if you take, and the part separation part is here, consider B, then here in this side how many parts are there, 1 part, and in this side how many parts are there, 2 parts are there. So that means in this case you have to write down the ratio 1:2. Is it clear? So the same length from A to D if you consider, if the ratio is consider you see, then how many parts you have to consider? For the first part 2 parts are there, here 1. So in this case we have to consider the ratio 2:1. So this type of trisection questions are also in your example. So now here your task is what you have to do. Here With the help of section formula, first of all you have to complete all the example questions, and after that you go through your exercise. So first of all you have to do the example questions and the exercise questions, and if any question or any doubt still remain there, then you can ask me. And one more thing about the triangle chapter, already we have done in section B, but in section A I think up to 6.3 we have done. So the triangle chapters, lots of questions are there, so that's why we discuss this triangle chapter in class. So here we have to complete the other chapters, so don't worry about this triangle chapter. Later on we have to complete this. Is it clear? Okay, thank you.